For this last example, I went ahead and filled in the chart. If you have not done that yet, go ahead and pause it and fill the chart in. Okay, so you should have the same thing I do, and once I got down here after 3 factorial, I just wrote it in terms of the factorial, which is fine because it's going to help us find a pattern better anyway. Don't worry about expanding this out. Okay, so to write our 6th degree polynomial, or our 6th degree approximation, for cosine, so we've got p sub 6 of x. Okay, so the first term, 1 divided by 1 times 1 is 1. And then this right here, anytime your nth derivative is 0, you're going to have 0 divided by something times something. So this term, these all disappear. So as a refresher, the 6 means the degree, not the number of terms. So I'm still only going to go up to x to the 6th, even though I won't have 6 or actually 7 terms if I were to start at 0. So my next term ends up being minus 1/2 x squared from this divided by this times this, and then plus 1 over 4 factorial x to the 4th, and minus 1 over 6 factorial x to the 6th. So this is my 6th degree polynomial. And then if I want to approximate cosine of 0.1, I can plug 0.1 into that. So cosine of 0.1 is approximately p sub 6 of 0.1, which would be 1 minus 1/2 times 1 over 100 plus 1 over 24 times 1 over 10,000 minus, okay, it's going to be a big number, 10 to the 6th. Okay, which comes out to be 0.995 from a calculator. Don't do that by hand. Okay, this one we can write an nth term for, and I want to use that to answer an additional question that is not written on here. But so let's look at the nth. Well, I don't need that over here, but let's go back to this right here. If I want to write that with a general term, don't put a 0 here. We might need to start at 1, so just a second. I'm going to have x to the, okay, so it's going to be x squared, x to the 4th, x to the 6th. This is x to the 0, so it looks like it is okay to start at 0 because I'm not dividing by, this is 2 factorial, 4 factorial, 6 factorial. I'm not going to be dividing by any 0. So let's start at 0, and then we've got something divided by n factorial. Is it n factorial? Okay. Actually, let's not do n factorial. Let's write this as 2n factorial because we don't have a 3 factorial, 3 factorial, 5 factorial, or 1 factorial. We only have 0 factorial, 2 factorial, 4 factorial. We only have the even factorial. So I'm going to write this as 2n factorial. And then my numerator is going to switch back and forth between positive and a negative. So I need -1 to a power. Now my first term when n equals 0 is positive. So if I raise this to the nth, -1 to the 0 is positive. And then when n equals 1, I would have a -1. So this is correct. Always check to see if you need an n or an n plus or minus 1 on your exponent of -1 for alternating series. Okay, and then we've got x to the 2n as our exponent. Okay, so this right here is the general form for cosine of x. And there's something that we can use this general form for to answer a question about finding a power series for something related to this. So what I mean by that is cosine is the derivative of sine. So my question here is, how can I use this result to write a power series representation for sine x? Okay, well, if you think back to the things that we did with power series in 9.7, remember we said that we could take the derivative of a power series or an antiderivative of a power series by taking the derivative of just the nth term in the summation notation. Okay, so since sine x is equal to the antiderivative of cosine x dx, then I can take the antiderivative of this. So I'm going to plug this in for cosine. So it's the antiderivative of the sum of negative 1 to the nth over 2n factorial times x to the 2n, and then I need my dx, use correct notation. And so this is going to be equal to the sum, and then negative 1 to the n is just a coefficient. Antiderivative of x to the 2nth would be x to the 2n plus 1, and then I need to divide by 2n plus 1. Well, if I have 2n plus 1 and then I'm multiplying it times 2n factorial, that's the same thing as 2n plus 1 factorial. So this right here is the power series, or the Maclaurin series for sine x, without actually having to write out all of these terms. Oh, sorry, I do need to consider c plus c centered at 0, sine of 0 is 0, so c equals 0, since sine of 0 equals 0. So that part ends up going away. So this series right here I get just from finding the antiderivative of this one. Okay, so don't forget that we can use series to find other series if one is the derivative or antiderivative of the other.